Dr. M. Uma Maheshwari. I am here to explain some of the applications of resource management technique. First of all, let us see what is a linear programming problem. A linear program is a mathematical model which indicates the goal and requirements of an allocation problem. Basically, it is the problem of allocation. Linear programming is a mathematical procedure for determining optimal allocation of the available resources in our hand. So let us check what is a linear programming problem. We need to attempt two things called maximization or minimization. For that, we have to have the decision variables, the function that is to be maximized or minimized, that is nothing but the objective function. The values of the decision variables must satisfy a set of constraints. The constraints may be some inequalities. Always a constraint should be a linear equation or a linear inequality. There are various steps in formulating a linear programming problem. I have stated here the 5 steps of formulation of the LPP. First step is to define the objective, that is whether the problem is a maximization problem or the minimization problem. Second thing is to define what are all the decision variables we are taking. Third thing is the mathematical function we have to write for the objective, that is the maximization or the minimization. Next step is to write the constraints, and the constraints should follow the inequality form, whether it may be less than or equal to or greater than or equal to, or it may be equal to form. The linear programming problem is of this general pattern, that is the maximize or minimize shall be our objective function, that is z equal to f of x1 comma x2 up to xn, and this objective function is subject to certain constraints called g of x1 comma x2 up to xn. So the constraint should follow the inequality form. Here the xj's are called the decision variables, and xj should be the non-negative constraints. Here it is stated. So let us check what are all the applications of linear programming. There are various applications in linear programming models. Product mix problem, diet problem, blending problem, media selection problem, assignment problem. The important one is a transportation problem. Also, there are various applications called work scheduling problem, production scheduling problem, inventory problem, and so on. First, we shall check what is a transportation problem. For example, I have considered a problem which is a problem of transportation. The Top Speed Bicycle Company manufactures a line of 10 speed bicycle nationwide. The firm has final assembly plants in 2 cities in which labor costs are low, Chennai and Bangalore. Its 3 major warehouses are located near the larger market areas of Hyderabad, Cochin and Coimbatore. Here the sales requirements for the next year at Hyderabad warehouse is given as 10,000 bicycles. At Cochin they need 8,000 bicycles, and at Coimbatore warehouse they need 15,000 bicycles. The factory capacity at each location is limited. Chennai can assemble and ship only 20,000 bicycles. Bangalore plant can produce only 15,000 bicycles per year, and the cost of shipping one bicycle from each factory to each warehouse differs, and these unit shipping costs are given in the tabulation. Chennai to Hyderabad, the transportation cost will be 2, Chennai to Cochin 3, Chennai to Coimbatore 5, and Bangalore to Hyderabad is 3, Bangalore to Cochin is 1, Bangalore to Coimbatore is 4. The company now wishes to develop a shipping schedule that will minimize the total annual transportation cost. So for that, we have to formulate this problem using linear programming. Again, we employ all the steps we followed in the formulation of linear programming problem. So first of all, we decide what is the objective function of this transportation problem. In order to define the objective function, we need whether it is maximization or minimization. We have already said that this transportation problem should be of minimization to its total annual transportation cost. So definitely this problem is a minimization problem. Accordingly, we define the decision variables as well as a set of constraints. Here the transportation problem is given like minimize z equal to 2x11 plus 3x12 plus 5x13 plus 3x21 plus x22 plus 4x23 subject to various constraints that is given in the tabulation. It is shown here. Thank you.